Hey, this is 7.4, Atmospheric CO2 and Particulates. Go ahead and check out the overview and set up your guided notes. Now, we have natural sources of carbon dioxide and other particulates, and a lot of these are review from previous lessons, especially biogeochemical cycles. But here's an overview. So lightning can provide abiotic fixation, in which we convert atmospheric nitrogen into NOx. Now, it will go into different forms of NOx, eventually resulting in nitrates, but the overall chemistry is N2 to NOx. Forest fires through combustion can release not just carbon dioxide, but also carbon monoxide, particulate matter, NOx, and also water. Respiration in plants and animals will release carbon dioxide from the glucose. And that's approximately 30% of the atmospheric carbon dioxide is coming from respiration. And conifers or evergreen trees can release volatile organic compounds in the forms of terpenes and ethylene. You don't have to know terpenes and ethylene. They're just examples of volatile organic compounds. But an example of this is the Great Smoky Mountains. They kind of have this just like haze over them, and that is because of the formation of tropospheric ozone naturally. And volcanic eruptions can release sulfur dioxide, particulate matter, carbon monoxide, and also NOx's. And then finally, decomposition. Aerobic decomposition will release carbon dioxide, and anaerobic decomposition, or decomposition without oxygen, will release methane. Now, the ocean is holding 50 times more carbon dioxide than the atmosphere. That is a lot, and about 40% of the atmospheric carbon dioxide comes from the oceanic carbon dioxide. There is this easy change between dissolved carbon dioxide and atmospheric carbon dioxide. So it's basically a reversible cycle. And geologically speaking, only 0.03% of the atmospheric carbon dioxide comes from volcanic eruptions. You can still use this as a source of carbon dioxide on, an FRQ response, but just understand that there are others that are far greater. Now, you have seen this Keeling curve before, and this is just a measure of atmospheric carbon dioxide concentration, and it has been taken over the past 60 years, and it has shown a gradual increase. And remember that there is a seasonal fluctuation. You're going to have higher amounts of carbon dioxide in the winter and lower amounts in the summer, because in the summer the plants are absorbing the carbon dioxide. Now, some sources of particulate matter it can be found in sea salt, in dust, or airborne soil. It can be found as a secondary sulfate, like a solid form, in acid deposition, which we'll talk about. It can be found in pollen, in black carbon from wildfires, also found in soot. It can be found in volcanic ash. Now, this was short and sweet. A lot of it was a bit of a review, but I would like you to respond to this check for understanding. And now respond to this prompt. Describe the fluctuations in the Keeling curve taken at Mauna Loa Observatory. I hope that this video was informative. I thank you for your attention, and I'll see you soon.